The following video works through an exam question on estimation and confidence intervals. We'll start by reading the question. The weights of packets of sultanas may be assumed to be normally distributed with a standard deviation of 6 grams. We have here the weights of a random sample of 10 packs, and we're being asked initially to construct a 99% confidence interval for the mean weight of packets of sultanas, giving the limits to 1 decimal place. So we're going to look at the sample mean distribution. And you can see here that the bulk of the marks are for this first part of the question. So we'll focus on that first. As always, I think the best thing to do is to write the distribution down to start with. They do seem to like this on the mark schemes. So we've got packets of sultanas normally distributed, so we're looking at a continuous random variable. And it's normally distributed. We don't currently know the mean. We've not been given that, so we need to work that out. But we're told the standard deviation is 6, so the variance must be 6 squared. The first task will be to work out the mean. Well, we can work out the mean by adding all the values and dividing by 10, because we've got 10 values here, so n equals 10 for our sample size. If we add them all up, if we add all our x values up, we get a total of 5,052. If we then divide that by 10, so the mean equals divided by 10, which is obviously 505.2. So we can put that straight in here. And we now have our distribution. We can go a bit further than this now and write out the sample mean distribution. So x bar, the sample mean, is distributed normally, as the packets of sultanas are normally distributed, and we've been told it's a random sample, so it's reasonable to write that with a mean. And remember, the mean for the sample mean distribution is the same, but the variance is divided by n. So there's our sample mean distribution. We're asked to construct a 99% confidence interval. I would always recommend you draw the bell-shaped curve here so we can have a look at what we're looking at. Well, we want 99% in here. In other words, in terms of area, because the area is 1, isn't it? Because the probability is 1, 0.99. That means that either end, remember it's symmetrical about the mean, either end we need 0.005. Same this end. Okay, so with a standardized distribution with the mean at 0, we can find how many standard deviations here we get all of this area less than. So we need the figure here that all of this area totals to 0.995. To find this, we look it up in table 4 in the formula booklet. the percentage points of the normal distribution table. And we want the lower half of it, the half where it's to 3 decimal places. So on the left column under P for the probability, that's this area, we look at 0.99, and then we move along the top columns to the 0.005, and that gives us the amount of standard deviations where this area is to the left of. And if we look that figure up, we get 2.5758. That also tells us that this here must be minus 2.5758. Because we've got naught in the middle, it's always the negative equivalent there. Okay, do you remember your confidence interval formula? The formula for the confidence interval for the lower limit and for the upper limit. Well, for the lower limit, it's the mean, which in our case is 505.2, and then we subtract the standard error. Well, the standard error is the square root of the variance here, isn't it? It's 6, a standard deviation, over root n. So it will be 6 over root 10 times the amount of standard deviations, which we've looked up from the table. So it's 2.5758. Well, we'll call it, we may as well do it fully, haven't we, for now, 2.5758. For the upper limit, it's the mean plus the standard error times the amount of standard deviations that we found earlier above or below the mean. And that gives us, instead of 0 here, it gives us the non-standardized version where we have our mean of 505.2 here. If we work these out, we get, for the lower limit, 500 point, and notice it says in the question to 1 decimal place. Well, we get 500.31, so we'll call it 500.3, and then for the upper one it rounds to 510.1. And there's our confidence interval. These figures here in real terms, non-standardized, instead of that many standard deviations, it's that, and under here, this figure here would be 500.3. So those are your non-standardized figures for this confidence interval for 5 marks. It then goes on to say, state why in calculating your confidence interval use of the central limit theorem was not necessary. Well, the reason we didn't need to use the central limit theorem is simply because we're told that we can assume that the packets of sultanas are normally distributed. And because they're normally distributed and we have a random sample, that means that the sample mean must be normally distributed. So we don't need to use the central limit theorem. Or in this instance, all you need to do on the exam paper is pretty much copy the question. The weights of packets of sultanas may be assumed to be normally distributed. You might want to mention it's a random sample, but you'll see on the mark scheme it's not necessary. To answer this last part of the question, first thing to do is to compare it with the original sample, the given sample as asked here. And you can see here that 3 packets are below, 7 are above. That's probably all you need to write for that first part. It then says, and your confidence interval. Well, as far as the confidence interval was concerned, we would expect sample means 99% of the time to fall between 500.3 and 510.1. That was our confidence interval. So that justifies the claim that 500 would be exceeded according to the confidence interval. So just comment on that really. Comment on what's happening here, 3 packets below, 7 above. And then for the second part, because the confidence interval suggests greater than 500, then that backs up the claim. And it's a 99% confidence interval, so it's pretty good. Okay, let's go through the mark scheme. You can see where the marks are coming from. These B marks mean you have to get the right answer. So you've got sample mean of 505.2. And here, anything which falls within 2.57 and 2.58, we got that answer there, didn't we? Which is perfect, really. For working out the confidence interval, there's the formula. Sample mean plus or minus the Z value, as far as we work it out, how many standard deviations above the mean, times standard deviation over root n for our standard error. And that's the formula you should use there. You do get follow-through marks on here. This means if you've got anything wrong in the previous part, like the mean wrong, or you get the Z value wrong, then the marks will follow through from that. And you should have got this confidence interval here, which is exactly what we got. Don't forget that because it asks to 1 decimal place, that is really what they expect. So try and make sure the answer's to 1 decimal place. And then for those last parts of the question, you can see here, this is fine. Basically, pretty much just rewriting weights of packets can be assumed to be normally distributed. And here, again, 3 out of the 10 have weights below 500 grams, is all they really wanted for that. And then for the next part, to state that the confidence interval suggests a value greater than 500 for the sample mean, and then to conclude that that justifies the statement. So it's quite simple, really. It's sometimes you feel that you've not done enough for 3 marks there, but you've just got to be confident and recognise what type of thing they're looking for. Have a go at a few more questions like this now. That will certainly give you confidence with these written parts at the end of the question. And also it will help you with the quite difficult process of working out confidence intervals. Good luck.